Okay, so I want to make a function one-to-one that's not one-to-one. So I want to basically restrict the domain of y equals x squared, or f of x equals x squared. Now, the first thing I'm going to do here is think about how can I maximize this function to get its max value, so to speak, and I want to do everything that won't repeat. So if you think about this function, everything starting at 0 here and then going upwards here or out on the x-axis will not repeat. Anything further to the left of 0 will repeat. So if I restrict the domain to x's greater than or equal to 0, then I can then indeed take a inverse of that function because it is one-to-one. So I just simply graph this as the square root function, which is really what it is, right? So if I graph this, I get this square root function like this, which is if I switch the x's and y's and solve for y, I get y equals the square root of x. And that's what the graph looks like, or f of inverse of x, if you will, equals the square root of x. So I can restrict the domain to x is greater than 0, and that way I can create an inverse. In this next problem, you've got f of x equals 4x minus x squared. Okay, in f of x equals 4x minus x squared, I graphed it here, and what I want you to do is try and restrict the domain to find the inverse of this function, okay? And then we're going to find it, you know, how do you find that function algebraically, or at least find an equation for that function? All right, so go ahead and give that a shot, and then come back after you've paused the video and given it a shot. So really quickly here, I took y equals 4x minus x squared. I switched the x's and y's, and I got y squared minus 4y is equal to negative x. So then then I went ahead and took and completed the square. I took half of b squared minus 4y is equal to, or plus 4 is equal to negative x plus 4. And then I square root both sides. And that should be plus 4 here. And then this is y minus 2 squared equals negative x plus 4. And then I'm going to square root both sides. And one of the problems here is that when I square root both sides, I do plus or minus, I'm going to end up with a function that doesn't work, so I'm only going to take the positive square root here, which is going to restrict my domain, and I'll talk about that in a second. Okay, and then I'm going to add 2 to it, so I get y equals the square root of negative x plus 4 plus 2. Okay, so this is an interesting problem because I have y equals the square root of negative x plus 4. But if I rewrite that, plus 2, if I rewrite that as y equals the square root of negative x minus 4, that means it's going to shift to the right 4 units, and then up 2. Now, restricting the domain, if I visualize what this graph looks like, I know the square root graph has, the parent function looks like that, so a negative x is going to flip across the y-axis, so it's going to look like that, and then shifted to the right 4 and up 2. So if we go right 4 and up 2, we're going to get this graph, and then it's going to look something like this, okay? And if you visualize this, what we have is this part of the graph here, from here down, reflecting across the line y equals x with the square root function. So what I did was I restricted the domain to be x greater than or equal to 2. And that'll give me a function, or a inverse function that is a function. That's a lot of talking on this problem, but I hope that's at least somewhat clear. The hardest part here, I think, for many of you will be, what did I do here? I took half of b, squared it, and I got 4, and I added that to both sides. And then I was able to write that as a binomial square, which I could square root, and boom, done. It's a quadratic, so to solve for it, I have to do some extra work here. All right, so that's examples 9 and 10. I think example 11, does y equals the square root of x have an inverse? the answer is clearly, since y equals square root of x is a v, then it does not have an inverse. So the answer to that question is straightforward, no. Okay, that'll be that for that video.